All right, welcome everyone to KS 2303 Signals and Systems here at University Malaysia Sabah. We're going to kick things off by looking at the single most important idea in this entire course, the absolute foundation of everything we're going to do. And that is simply, what is a signal? Okay, let's dive right in.
So, before we even touch a single formula, I want to start with a bit of a puzzle. Take a look at these three things: a phone call, a heartbeat, and the temperature in your room. Now, on the surface, they seem totally different, right? But they all share a hidden connection, a common pattern that is the key to this whole subject. So, first up, a phone call. When you talk, your voice is creating these tiny vibrations in the air, right? The pressure of those sound waves isn't just one steady value. It's constantly changing, up and down really, really fast. And it's that constant change, that variation over time, that's actually carrying the information, your voice. Okay, now think about a heartbeat showing up on an ECG machine. What a doctor is really seeing on that screen is a picture of the electrical voltage that your heart generates. And with every single beat, that voltage spikes and falls in a very specific, predictable rhythm. Again, it's something that's changing over time. And finally, let's take something really simple, like a temperature sensor. Maybe the one in your air conditioner. Its whole job is to just keep measuring the room's temperature. And that value, well, it's always changing, isn't it? It goes up and down slowly throughout the day. So, did you spot the pattern? In every single one of those examples, we had some kind of physical quantity: sound pressure, voltage, temperature. And the key thing is that it varies. It changes. And for pretty much everything we'll do in this course, it's changing with respect to one big independent variable: time. And that right there, that pattern, well, it leads us straight to our very first formal definition. A phone call, a heartbeat, the temperature, these are all what we call signals. A signal is just a way for us to use math to describe some physical thing that changes over time or, some other variable. Okay, so now that we know what a signal is, we need to sort them into two big families: continuous time and discrete time. Getting this difference is absolutely crucial. And here's the really cool part. You don't even have to think hard about it, because the way we write them down, the notation itself is a dead giveaway. So first up on the left, you've got a continuous time signal, or CT for short. The big thing to notice here, the notation. It's x of t with parentheses, round brackets. A perfect example is a sine wave. It's a smooth, unbroken curve. It has a value at every single possible instant in time. At 1 second, at 1.5 seconds, even at 1.00001 seconds, it's always there. And then on the other side, we have discrete time signals, or DT. And look, the notation is totally different. It's x of n with square brackets. This is a huge clue. Unlike the smooth wave, a DT signal only exists at specific points in time, at integer values like 0, 1, 2, 3, and so on. It's not a continuous movie. It's more like a series of snapshots taken one after another. And this brings me to the most important rule I want you to learn today. You never, ever have to guess what kind of signal you're looking at. It's not a mystery. The notation tells you the answer right away. That's it. It's an incredibly powerful shortcut. So, from this point on, I want you to have this little mental checklist. Anytime you see a signal in this course, just quickly run through these steps. What's the variable? What kind of brackets are they using? Boom, you instantly know if it's continuous time or discrete time. Simple as that. And believe me, as we get deeper into this course and start talking about more advanced stuff, this one simple idea, just being able to read the notation, is going to be your guiding light. It keeps everything clear. So if you only remember one single sentence from our entire chat today, please let it be this one. The notation tells you everything. Parentheses mean continuous. Square brackets mean discrete. That is the bedrock we're going to build everything else on. And this is what's so cool about what we're learning here. We just figured out something fundamental about a signal just by looking at the type of brackets it uses. So that begs the question, right? If the notation reveals that, what other secrets are hiding inside that little equation? What can it tell us about the signal's energy or its frequencies? Well, finding that out, that's what the rest of this course is all about.